Basically what we're doing here today, guys, we're talking about how BG products make good products better. And the demonstration that we're going to show you now happens to deal with oil. We're going to use a simple thing called this bearing burning machine, and all it's really designed to do is to tear the garbage or to tear the crap out of a bearing. Pure and simple, that's what this machine does. It's a friction test. What we're going to show you here is how an oil, an everyday oil that's used by most or used by many, doesn't matter if it's Valvoline, Pennzoil, Quaker State, or whatever it happens to do, and how that oil happens to play on this friction machine. The best form of lubrication known to man is what we call hydrodynamic. Hydro means it's wet, and dynamic means that it moves. So we're going to pour a little of this oil into the oil bath, sufficient enough to where you can see that we have flow going over the bearing. What we're now going to do is we have a fresh bearing placed into the torque wrench. And we're going to go ahead and apply pressure on this thing, just sufficient enough to make the bearing seize. And as we go ahead and apply this, you can see it gets pretty loud, and it gets pretty loud, and it gets pretty loud. Then all of a sudden, we're going to get to a point to where we stop. Now, I can't read that, but I'm going to have our able-bodied assistant, Mr. Ralph, take a look at that. Where are we at for foot-pounds, Ralph?
About 22, 23.
We're about 22, 23 pounds of pressure to where we stop it. I'm going to do it one more time, and you're going to see that it's going to go ahead, and all we're simply doing is squeezing out the lubrication.
About 25.
Again, all that's happening here is that we're forcing the oil out. The oil's acting as a barrier between one metal surface and another, and its job is to try to put a barrier between that so it can continue to lubricate. And at about 25 pounds of pressure, we seize the bearing. Okay, 25 foot-pounds. Now, to continue the demonstration, what we're going to do is we're going to add MOA. We're just going to leave it alone. We're going to leave the bearing where it is right now, and we're going to add a little MOA. I can go like that. I'm a real man. I can do it with my knuckle. We're just going to pop this a little bit, and I'm going to put just a little bit of oil on that bearing. Now, if I were to take this bearing out at this time, if I was to take this bearing off at this time and to show you what it would look like, I'll wipe it down. You would notice that we have can you see the scarring on that, Dave? I mean, we've got a significant scar on that particular bearing. This started out smooth. Now what we're going to do, I'm going to leave that bearing in the same spot that it is right now. Do we have if we were to take a screwdriver and rub it across, that you would feel that there were ridges that were cut in that scar. There are significant cuts. Now these things are just typically going to wear, this is called what we call worn parts. You can have worn parts with this particular demo. Now what we're going to do now is I'm going to leave that in the same spot that it is right now. I'm going to put it back on the machine. We're going to go ahead now and show you how we make a good product better. Again, oil, the purpose of the oil was to add some lubrication, to fight some friction, to take away, dissipate heat, and add cleaning. MOA, this particular product, will do more than just a lubricant, but the purpose of this demonstration is to show you the lubricating capabilities and how we improve that in the oil. We're going to put just a few drops of MOA in. In fact, we can use this pipette to show you that we're not going to use large amounts. Again, we're going to add it to the oil bath, just a few drops of MOA. We're going to take this to 25 pounds of pressure. Now, if you've noticed, a couple of things have happened. Number one, we still have movement. What would that tell you? That would tell you that we've gone ahead and we've increased the lubricity in here. The friction modifiers in this particular product have gone ahead and added film strength to the oil. Now the goal here is not to seize the oil or to push this down until we have 400 or 500 or 600 pounds of pressure. is simply to show you what happens when we add it to motor oil. Now, I'm going to show you one improvement on our bearing. Before, where we had rough ridges in this cut, we now can take our screwdriver and the ridges become smooth. Now what's happened here is basically that we've gone ahead with the MOA, and we've allowed the MOA to go ahead and work its way into the metal to where our rough edges become smooth. Call it magic, call it whatever you want, but basically what it happens here is that we're having a process take place where we're basically filling the gaps, those asperities in the metal. And that's what we're doing here. Now that's what happens if we start with a used vehicle. If we started with a used car, the question becomes would you rather have your parts smooth or rough? Would you rather have continued wear, or would you like to seize the wear? And that's what this will do. Well, let me show you what happens now when we add MOA to a new vehicle, and we're going to do that simply by turning this to a new fresh spot, just moving your bearing slightly. We're going to take this to 25 pounds again. This is the worn spot when we started with oil only and then added MOA at a later date. This is a spot when we started using MOA when the car was brand new. I think there's a significant difference. If in fact this were your car, where would you want to start using MOA? Before, when it's new, or after the wear processes begin? That's the demo.